Good morning, everyone. First of all, I would like to thank the organizers of this international conference on materials and energies for accepting my abstracts. So I am going to present my work entitled Study of Magnesium Oxide Nanoparticles Based Hybrid Nanocomposites. The plan of my presentation will be as my talk will first as introduction, what is meant by polymer nanocomposite. Then I will talk about the procedure for fabrication of polymer nanocomposite. Next, I will discuss the analysis of experimental results. Finally, general conclusion and future scope. Let's start with introduction. When a polymer is reinforced or dispersed with nano-sized filler, the resulting material is called polymer nanocomposite. At least one dimensions of filler should be less than 100 nanometer. This is done in order to improve the performance properties of polymer. The present study has been carried out with the following objective: fabrication of magnesium oxide nanoparticles and magnesium oxide PVC nanocomposite. Then study the structural and optical properties of nanocomposite sample. Magnesium oxide nanoparticles were prepared by sol-gel method by dissolved of magnesium acetate dehydrate in absolute ethanol under magnetic strain for 24 hours to obtain a white gel. After that, the mixture was dried at 100 degrees Celsius for 24 hours and annealed at 950 degrees Celsius for 36 hours to obtain magnesium oxide nanopowder. This diagram summarizes the process for preparation of magnesium oxide PVC nanocomposite. First, we have to dissolve powder PVC in THF for 30 minutes under stirring to obtain a viscous transparent solution. Then we take a weight of magnesium oxide nanoparticle in THF. After that, the mixture of two solutions for 1 hour. Deep coating technique was used to deposit magnesium oxide PVC nanocomposite on glass substrates. We move now to the characterization of polymer nanocomposite. We start with XRD diffraction of magnesium oxide PVC. From X-ray diffraction spectra, the pure PVC film show an amorphous structure. However, with the addition of magnesium oxide nanoparticle 3% and 5% in the PVC matrix, we obtain a crystalline structure with appearance of two peaks at 36 degree and 43 degree correspond to the cubic phase of magnesium oxide. From the table of structural parameters of magnesium oxide PVC, we can see that the approximation of grain size between 21 to 42 nanometers. The optical energy band gap of all films were determined using Toc plot method. We are found that the gap of PVC 4.02 electron volt, then it reduced to 3.6 electron volt for 5% magnesium oxide PVC. The photoluminescence spectra of magnesium oxide PVC. The spectra of pure PVC show no emission peak Beside, the other samples have yellow emission band at 550 nanometers due to the transition between single charged oxygen vacancy and the photo-excited holes in the valence band of magnesium oxide nanoparticles. The general conclusion are as the experimental work revealed that fabrication of magnesium oxide PVC nanocomposite thin films were achieved by a sol-gel method. The structural studies confirmed that the magnesium oxide nanoparticle change their crystalline pure PVC and indicate the well dispersion of the nanoparticles in the matrix, and the increase in the nanoparticles content also enhanced the crystallinity and grain size of nanocomposite. The optical studies demonstrate that all films are transparent in the UV visible region, and the optical band gap decreased with increasing of dopant, which improve the optical properties and which can be used as promising materials for optical display system applications and also for dye removal. Thanks a lot for your kind attention.